Hello, this is T Chapman 500, and today I'm going to be showing you a binary to decimal converter using Logisim Evolution Holy Cross Edition. Now, the primary motivation for this video is Ben Eater's video where he does binary to decimal conversion in software using a divide by 10 algorithm. Now, I'm doing this binary to decimal conversion using hardware instead of software, and using the divide by 10 algorithm in hardware is slow. For a 16-bit number like what we have here, it will take a minimum of 80 clock cycles. That's 16 clock cycles per digit times 5 digits. The method that I'm using here, which I found online, links to a few resources will be in the description, involves checking to see if a number stored in a digit register is greater than 4. That's what this set of gates does. And then if it is greater than 4, we add 3 to whatever number is in this register. That's what this part of the circuit does. And then we shift everything to the left, taking input from the previous digit and sending output to the next digit. So to demonstrate, I'm going to set the write enable high, and I'm going to set a random value into here. That looks good. I'm going to set the value into the register with the clock signal. Then I'm going to put the register into shift mode. Then we should see after 16 clock cycles the correct output here. So we should see a 2 here, a 3 here, 7 here, 2 here, 3 here. So 1, 2, 3, 4. Now because this value is greater than 4, we're going to add 3. 5 plus 3 is 8. Then we're going to shift it over. So there's going to be a 1 in this register. And this register would be 0, but we're also shifting in a 1 from the load stage. So these two registers will be 1. So that's 5 clock cycles, 6, 7. So now the value in this register is 6, which is greater than 4. 6 plus 3 is 9. So this value would be 9. We shift it over. So there will be a 9 stored in this register and a 2 stored in this register. And I lost count of the clock cycles. So I'm just going to put a clock counter on the screen so you know how many clock cycles there are. And I'll just keep going till I get the correct answer. There we go. 2, 3, 7, 2, 3, which is exactly what we have here. That is the correct answer, and we got it in 16 clock cycles. Now, I do not know if this method is faster in software. And actually, I don't believe it's faster than software because you would have to use bit masks, you would have to shift to the right, you would have to then shift to the left, and all sorts of things to get this done. That is, if you went for the most compact method. And you might still have to do some of that even if you used 8 bits for each digit instead of 4 bits. So in software this might be slower, and actually I believe it's slower, but I have not tested it yet. Once I do test it, or if somebody else tests it and can, say, leave a comment or post a video on it, then I'll link that video to an end card, or not an end card, a whatever those things are that appear in this corner of the screen. Oh, by the way, I will post this circuit on GitHub. Link to that will be in the description. So, I hope you enjoyed the video. Don't forget to rate, comment, subscribe, and share, and I will see you in the next episode. This is T Chapman 500 signing off.